talk about a sun jar. Now, Les has asked us about sun jar. It's a project we've been selling for a little while now, and actually came out of some work we did with a school. So, I don't know if you can see here, we've got a little jar. I think we might do better we'll do a close-up in a minute. I'm just going to talk about it first. So basically, a sun jar is it's like a garden light. So basically, we've got a solar cell that charges a battery during the day. At night time, a light comes on. But it's a very clever little circuit, and it's sustainable. You use the solar cell to recharge the battery. It's a rechargeable battery, so you don't have to throw batteries away. You can call it sun jar, and that people can use it well, in here, like this is an example. It's a recycled jam jar, an enclosure, but people could use any old kind of jar really, or piece of old packaging from a home to make an enclosure, or you could go and do a really professional looking project. But the idea is to try and make it around sustainability and reuse. So what I'm going to do is I'm going to sort of show you a little bit more about the circuits, which we'll do a close up. Okay, so we'll take it out of the jar so you can see it properly. What we've got is a solar cell and a rechargeable AA battery. Now, what happens is when it goes dark at night time, the LED comes on. So I think it's a fantastic circuit, and the reason though it's very simple in operation, the design circuit's actually quite neat and smart. For instance, we could have a separate LDR to detect the light level to see, know when it's gone dark. But the way this circuit works is actually we use the solar cell itself to detect the light level. So during the day, there's sun falls on the solar cell. It generates about 2.5–3 volts, and then that charges the single AA battery. As the light level falls on the solar cell, the voltage it generates actually drops. Now the circuit detects that, so when it drops below a threshold, so it's getting darker, the voltage off the solar cell is going down, until it goes below a predefined threshold level, at which point one of the transistors detects that and says, okay, it's dark now, so we're going to stop charging the battery, and we're going to actually turn the LED on. Now, so the solar cell is used to detect the light level. In the day, it charges the battery. At night time, obviously, the light drops, it switches the LED on. Now, this is another neat little bit. This battery only produces 1.2 volts, but the LED needs in excess of 2 volts to work. And you say, well, how does this actually, how does the circuit work then? Because there's not enough voltage for the LED to actually work. Obviously, it does. Well, the way it works is it's got like a little like a dual feed kind of circuit in here using some inductors. So the LED, even though you look on that LED, to me it looks like that is on all the time. Yeah. In effect, it's only on for about half to a third of the time, and it's flickering, but it flickers so fast your eye can't perceive it. So like a TV used to work, that would flicker, but it just does it so many times a second that the perception is that it's always on. So this LED is thousands of times a second being pulsed on. When it's off, some voltage is being stored in the two inductors you see here, well, one of the inductors. And then when it's on, the inductor is being discharged in series with the battery to step the voltage up to give the required voltage for the LED. So the LED can get enough voltage to actually turn on when required. The second inductor is used to create an oscillating circuit, which drives another transistor, and it's that oscillator circuit that's flicking on and on off all the time that chops and turns the LED on thousands of times a second. So we've got two inductors, the same value, so you can't get in the wrong place. One used to turn the LED on thousands of times a second, and the other one is used to step the voltage up to a level that's high enough for the LED to work. So, like I say, in operation it's incredibly simple, but it's quite elegant in its design, the way it works. We could have had lots of other parts to do that. We could have had more batteries. If we'd have had more batteries, we would need a more expensive and larger solar cell. So the way it works is actually quite smart. So I hope people can understand my explanation there as to how this solar garden light works. But yeah, it's a great little project, and I think it's got quite a lot of applications out there for people doing sustainability projects, or they want to create their own garden lights and those kind of things. Obviously, one thing to remember is the amount of charge that goes into the battery during the day is dependent upon the strength of the sunlight that falls on the solar cell, and also the length of time. So in summer, got very long days, and it is sunnier on those days, so the battery charges more, and consequently, you know, at night time when it comes on, it will stay on for a lot longer. So in summer, you probably find it stays on all night or 8 hours, whereas in winter, when the days are shorter and the sunlight's not as bright, you may find it only stays on for, say, 4 hours a night. But that's just a factor of the amount of the intensity of the sunlight falling on the solar cell and the length of time for which it falls on there. But yeah, so it's quite a smart, neat little project there.